Welcome to the Physics 202 class again. This time we're talking about the Bohr's model of atom. We've been talking about the models of atom. We talked about the Rutherford's model of atom. We talked about the Plum-Pudding model of atom, which is by J.J. Thomson. Now we're talking about the Bohr's model of atom. After Rutherford did his own discovery and with his students Geiger and Maxwell, they were able to discover that an element exists this way with a positively charged nucleus. They stated the planetary model of an atom. They said the atom is okay, sorry about that, it had to be paused. So the Rutherford model of atom says that the atom consists of a core nucleus, a positively charged nucleus, where most of its mass is concentrated. We did this. So it says this is the nucleus of the atom, where most of its charge is concentrated, its mass rather, and negatively charged electrons are orbiting round it, the way the planet orbits round the sun. Thus, this was given the common name, the planetary model of atom. But as they're doing this, they will be radiating energy, and it is possible for this element, for these electrons to, at the end of the day, disappear spirally because of the centripetal force, into the nucleus of the atom. That means, according to Rutherford, an atom exists, but an atom is not stable. Is that possible? No. An atom should always be stable because we are stable. We are all made up of atoms. So if atoms are not stable, then we should be unstable. And even if that disappearance of the electron into the nucleus occurs, it occurs in a fraction of seconds. I mean, high fraction of seconds. That means it is very, very much impossible for this to be like this. So Bohr, though he won the Nobel Prize on this, but Bohr had to do some other findings after him, and Bohr was able to determine that, yes, Rutherford model of atom is correct. That is the first postulate of Bohr atomic model. The second is now that, but the electrons orbit in specific energy level. They orbit in specific energy level. That means this is Rutherford model. Bohr now says it is supposed to be drawn this way: the nucleus, the electron in this place, 2 will be in the K shell, the electron here, the electron here. So Bohr now used the simplest element known, the hydrogen element. He said these are the energy levels. This is energy level 0. This is energy level E1, energy level E2, energy level E3, up to the energy level En. It now says the electrons in each energy level do not radiate electromagnetic wave. They do not radiate energy. But they can go from the ground state of an atom. An electron that is in this level can be in this level, but can go from this level to another energy level. So from E0, that is E0, to E2. The electron gets here, the atom means the atom is excited. The atom is excited because the electron moves from a lower energy level to an upper energy level. So once that is done, the transition brings about, the thing is going to come back to that energy level. Once it comes back to that energy level, it's going to lose an energy. Energy that is having a magnitude here like this, the energy level here, the higher energy level, which is E2, minus the lower energy level, which is E0. And the magnitude of the energy loss is going to be equal to NHF, where H is known as the Planck's constant, and H is equal to 6.63 times 10 raised to the power of negative 34 joule second. So this is Bohr's model of atom. It says that the Rutherford model is correct. 2, the electrons orbit in specified energy level. It is not like this that is irregular. This is in specific energy level. The electrons here is here, the electrons here are here, the electrons here are here. And it also says they do not radiate energy. They do not radiate electromagnetic wave. So when an electron jumps from a lower level, when an electron is originally here, the element is in ground state. When it is here, it is in ground state. But once an electron jumps from a lower level to a higher level, the element becomes in excited state. Its state changes to the excited state of the element, and thus there is going to be a loss of energy. And the energy now given off is going to be given by the magnitude E2 minus E0, that is the higher level minus the lower level. If it got to E3, it will be E3 minus E0. So then the change in energy level is given by the Planck's constant times the number of the shell it got to, that is the level, energy level, and F is the frequency of the radiation given out. Thank you.